What's up guys, welcome to another video. In this one I will be deriving the Legendre duplication formula, which is what you can see on your screen right now. And to do that, I want to use exactly what we've derived in the last video, namely a beta of x, y is equal to gamma x, gamma y over gamma x plus y. Now, what I want to do is I want to set x to be equal to y, and I'll just rename it to z because that's the variable I've used up here. So we have beta of z and z is equal to, notice on top we're going to have gamma z times gamma z, which is just gamma squared z, or gamma of z plus z, which is 2z. Now remember that the beta function has a couple integral definitions, and I'm going to be using one of those. But first I just want to swap the left and right hand side for convenience purposes. So we have the integral from 0 to 1, t to the z minus 1. The z here is supposed to be the first argument, times 1 minus t to the z minus 1, and this is supposed to be the second argument, obviously. And here, I want to perform a little substitution, which I'll put right here on the left. It's not a very obvious substitution, but in the end, it makes it so the integral looks a bit more symmetric and it's easier to work with. So yeah, we're gonna let t be 1 plus x by 2. Now this implies that 1 minus t is, well, 1 minus x by 2. See what I meant by it's more symmetric? Now if we derive the first equation, we get that dt is dx over 2. And therefore we have an integral from, if you plug 0 for t, we get that x should be negative 1, and if we plug 1 for t, we get that x should be 1. So we have the integral from negative 1 to 1 of t becomes 1 plus x by 2 raised to the z minus 1 times 1 minus x by 2 again to the z minus 1, and dt becomes 1/2 of dx. Now I'll bring the half to the outside, integral from negative 1 to 1, and I'll combine both of these because they have the same exponent. So we would have 1 plus x times 1 minus x, which is a difference of 2 squares, it's 1 minus x squared, over, 2 times 2, which I'll write as 2 squared for now. All of that to the z minus 1 power dx. Now notice that we have an even function, right? 1 minus x squared, we're integrating an even function over a symmetric interval, meaning we can simply integrate from 0 to 1 and double the result instead of integrating from negative 1 to 1. So the 2 will cancel out the 1/2 we have in front. But we can also bring out this here, the 1 by 2 squared, the z minus 1, because it's a constant in the x world. So we have 1 by 2 squared to the z minus 1. I'll arrange that afterwards. Times the integral from, that's an ugly integral, times the integral from 0 to 1 of 1 minus x squared raised to the z minus 1 dx. As I said, we can arrange the constant term out front. This is 2 to the negative 2 power raised to the z minus 1. So we effectively have 2 raised to the 2 minus 2z times the integral. Before we do that, actually, I want to do another substitution. We're gonna let x squared be equal to t, which implies that x is equal to t to the 1/2, which further implies dx is 1/2 t to the negative 1/2 dt. So the integral still goes from from 0 to 1, sorry, but this time we have 1 minus t to the z minus 1 times dx, which becomes 1/2 t to the negative 1/2 dt. The 1/2, when we bring it out front, will reduce the power by 1, so we have 1 minus 2z times the integral from 0 to 1 t to the negative 1/2, 1 minus t to the z minus 1 dt. Now notice that this integral right here is precisely what I've used up here for the beta function, only that this first argument is replaced with 1/2. So we have that gamma squared z over gamma 2z is equal to 2 to the 1 minus 2z times beta of first argument is 1/2 and the second argument is z. Now we can, just like before, expand this beta function in terms of gamma function, which gives us 2 to the 1 minus 2z rather, gamma 1/2 gamma z over gamma z plus 1/2. And you'll notice we can divide by gamma z on both sides, remove one of those, and maybe you know that gamma 1/2 is square root of pi. And if you don't, that's fine, I'll probably make a video on that in the future, but right now you can take it for granted. So finally, well, not finally, but almost finally, we have gamma z over gamma 2z is equal to 2 to the 1 minus 2z root pi times 1 by gamma z plus 1/2. Now I'm just going to rearrange things so that it looks like what I wrote at the top of the page. We have gamma z plus 1/2, that's bringing this to this side, is equal to gamma 2z, bringing this over to that side, times 2 to the 1 minus 2z root pi. And that's it. That's exactly what we had up here. If you're wondering what this can be used for, I'll again probably make a video on this in the future, but I did use this recently in an integral, so yes, probably going to make a video on it. But that's the end of this one, so I hope you enjoyed the video. If you did, make sure to leave a like, subscribe, all the YouTube stuff. And yeah, if you have queries or suggestions, please make sure to comment them. Alright, see you in the next video.